There is a landscape feature that covers vast areas of the American West that geologists classify as desert. The official explanation for these desert regions is that they are areas of low rainfall, that the arid climate has persisted for millennia, that the landscape is essentially natural, shaped by wind, water erosion, and geological processes operating over deep time. But if you look at the desert landscape carefully, if you examine the composition of the desert more closely, if you consider what the landscape actually contains, a different picture emerges. The deserts of the American Southwest are not simply natural arid landscapes, they are dumps. They are the locations where the debris from massive mining operations has been deposited. They are constructed landscapes, created through the systematic removal of material from somewhere else and the deposition of that material here. What we call desert is actually the waste product of enormous excavation projects of unknown origin and unknown purpose. I came to this observation through a different path than most people. A geologist who specializes in sediment composition was examining samples from various desert regions. She noted that the composition of the sand and soil in the deserts did not match what would be expected from natural weathering of the bedrock in those locations. The material appeared to have been transported from elsewhere. The particle size distribution was consistent with material that had been mechanically processed, crushed, sorted, transported. The composition suggested that the desert was not a natural landscape, but a constructed one, created through the deposition of processed material. Consider the composition of desert sand in various regions of the Southwest. Sand in deserts is typically characterized by particle size, mineral composition, and sorting. Natural sand created through weathering of local bedrock typically shows particular characteristics. The sand in many Southwest deserts does not show those characteristics. The sand appears to be well sorted, suggesting mechanical processing. The mineral composition often does not match the local bedrock, suggesting the sand was transported from elsewhere. The distribution of sand across the desert does not follow patterns consistent with wind deposition or water erosion. The distribution suggests deliberate placement, systematic deposition. The question of where this material came from is worth considering seriously. If the desert is composed of debris from mining operations, the question becomes, where was the mining? Where were the canyons or formations that material was extracted from? What was being mined? Why is there no record of such massive mining operations? The official geological narrative does not address these questions because it does not acknowledge that the desert might be constructed rather than natural. The canyon systems of the American Southwest provide a clue. The Grand Canyon, the Canyonlands, the various slot canyons and formations, these systems are characterized by having had enormous amounts of material removed. The canyons themselves are excavations, but the question is, where is the material that was removed? If the canyons were created through water erosion, the eroded material should be found in sediments downstream. But much of the material is not accounted for in the sedimentary record. The material has disappeared. Or rather, the material is present but has been reinterpreted as something else, as desert, as geological formations, as natural landscapes. The possibility that the canyons were created through mining rather than through water erosion changes how the landscape should be understood. If material was systematically extracted from canyon systems through deliberate excavation, that material would need to be disposed of somewhere. The most logical place would be in adjacent areas, in locations that could be easily reached from the excavation sites. The material could be dumped, spread, allowed to settle. Over time, wind would further distribute it. The result would be the appearance of a natural desert landscape covering the disposed mining debris. The systematic nature of the canyons supports this interpretation. The canyons do not appear to be randomly distributed. They appear to follow particular patterns, particular geological formations. The extraction appears to have been systematic, targeting particular rock types or formations. The evidence of step-like patterns in canyon walls, which we examined in previous discussions, could represent the systematic nature of the extraction process. If mining was occurring, systematic extraction would have left systematic patterns. Consider the scale of material that would have been removed to create the Grand Canyon alone. The canyon is over a mile deep and extends for 277 miles. The volume of rock removed is almost incalculably large. Where is this material? If water erosion created the canyon, the material should be found in sediments in the Colorado River Basin and beyond. But much of the material is unaccounted for. The material could be present as desert sand and soil, reinterpreted as natural desert landscape. The question of why such massive mining operations would have occurred, what was being extracted, requires consideration. One possibility is that the material being extracted was not simply rock, but contained valuable minerals or elements. Another possibility is that the excavation was not for material extraction but for other purposes: water management, infrastructure development, territorial modification. Another possibility is that the excavation was part of a larger-scale terraforming or landscape modification project of unknown purpose. The distribution of deserts in the southwest is worth examining in relation to canyon systems. The deserts are often found adjacent to canyon systems, in locations that would be logical for disposing of excavated material. The largest deserts, the Mojave, the Sonoran, are in proximity to major canyon systems. The distribution suggests a relationship. Canyons were excavated, material was removed, debris was deposited adjacent to the excavation site, creating what appears to be natural desert landscape. The particle size distribution in desert sand also provides evidence. Desert sand that has been created through wind erosion of natural rocks typically shows a particular distribution: finer particles transported farther, coarser particles settling closer to source. But much southwest desert sand shows a different distribution, more consistent with material that has been mechanically crushed and processed, then deposited. The uniformity of particle size across large desert areas is more consistent with dumped material than with wind-eroded material. The color and composition of desert sand in various locations also provides evidence. Sand in some desert regions is reddish, indicating iron oxide content. Sand in other regions is white, indicating silica dominance. Sand in other regions is dark, indicating darker mineral content. These variations in composition across the desert do not follow patterns consistent with wind erosion and deposition. They follow patterns more consistent with material from different source locations having been transported and dumped in particular areas. The variations suggest that different desert regions contain debris from different excavation sites, transported and deposited in those locations. The official geological narrative does not account for these observations. The narrative treats the desert as a natural landscape created through climatic and erosional processes. The narrative does not consider that the desert might be a constructed landscape created through the deposition of mining debris. The narrative does not ask where the enormous volumes of canyon material have gone. The narrative does not investigate whether the desert composition is consistent with natural desert formation or whether it is consistent with dumped mining debris. The suppression of this alternative interpretation follows the pattern we have observed in other suppressed histories. The alternative interpretation is not explicitly censored, it is simply not investigated. The questions are not asked. The evidence is not examined. The desert is treated as natural, and therefore the question of its composition is not a serious geological question. The alternative interpretation that the desert is constructed, that it is debris from mining operations, is not treated as credible because it has not been seriously investigated. What remains is a landscape that contains within it the evidence of its constructed nature, if anyone is willing to look carefully enough. The composition of the sand, the distribution of material, the relationship between canyons and adjacent deserts, the patterns that suggest systematic deposition rather than natural formation, all of this evidence is visible to anyone who examines it carefully. The evidence suggests that the deserts of the American Southwest are not natural landscapes but constructed landscapes created through the deposition of debris from massive excavation projects. The specific evidence that the deserts of the American Southwest contain mining debris rather than representing natural desert landscapes becomes clearer when you examine particular regions in detail. The composition of desert soils, the distribution of particular mineral types, the presence of processed material in areas where natural geological processes would not produce such material, all of this evidence points toward constructed landscapes created through the deposition of excavated debris. Consider the Mojave Desert, one of the largest desert regions in North America. The Mojave covers approximately 54,000 square miles across California, Nevada, Utah, and Arizona. The official geological narrative describes the Mojave as a natural desert landscape shaped by arid climate, wind erosion, and water erosion over millions of years. But the composition of the Mojave's soils and sand contains evidence inconsistent with this narrative. The Mojave contains extensive deposits of what is called caliche, a hardened layer of calcium carbonate, that forms in arid soils. The distribution and composition of these caliche deposits suggests mechanical processing and deposition rather than natural formation through weathering. The caliche in the Mojave is not distributed according to what would be expected from natural soil formation processes. The deposits are extensive, uniform in composition across large areas and show evidence of having been sorted and processed. If the caliche had formed naturally through weathering and leaching processes in the Mojave's arid climate, the deposits would show more variation in composition and would be distributed according to patterns of water flow and rock type. Instead, the caliche shows characteristics of material that has been mechanically processed, transported, and deposited systematically. The Sonoran Desert, another major desert region covering parts of Arizona, California, and Mexico, similarly shows evidence of constructed composition rather than natural desert formation. The Sonoran contains extensive deposits of particular mineral types, iron oxides, silicates, aluminum compounds in concentrations that do not match the local bedrock. The distribution of these minerals across the Sonoran follows patterns that suggest deposition rather than natural weathering. The minerals appear to have been concentrated and transported to the Sonoran from other locations. The question of where these minerals and processed materials came from points back to the canyon systems. The Grand Canyon, the Canyonlands, the Gunnison Gorge, and numerous other canyon systems in the region all show evidence of systematic excavation. If massive amounts of material were being extracted from these canyons, that material would need to be disposed of. The adjacent deserts would be logical locations for such disposal. The material would be transported from the excavation sites and deposited in the deserts. Over time, wind would further distribute and bury the material. The result would be the appearance of a natural desert landscape overlying a base of mining debris. The relationship between specific canyons and specific deserts supports this interpretation. The Grand Canyon is adjacent to the Mojave and other desert regions. Material excavated from the Grand Canyon could be transported to these adjacent deserts. The Canyonlands are adjacent to other desert regions. The Gunnison Gorge and other canyon systems are located near particular desert regions. The proximity of canyon systems to deserts, combined with the evidence that desert composition does not match natural desert formation processes, suggests that the deserts contain debris from the adjacent canyons. The particle size distribution in desert sand also provides evidence of systematic mining and deposition. Desert sand created through wind erosion of exposed rocks typically shows a particular range of particle sizes. Wind can only transport particles of certain sizes effectively. Very fine particles are transported great distances. Coarse particles settle close to source. Medium particles are transported intermediate distances. This creates a characteristic distribution. But much southwest desert sand shows a different distribution, more uniform particle sizes across large areas, suggesting mechanical crushing and uniform deposition rather than natural wind transport and deposition. The sorting of desert material also suggests mining and processing. In particular desert regions, materials appear to be sorted by type silica-rich sand in some areas, iron oxide-rich material in other areas, calcium carbonate deposits in yet other areas. This sorting is not consistent with natural mixing of weathered materials. The sorting is consistent with processed mechanically separated materials being deposited in particular locations. The separation and sorting would have occurred during the mining and processing operations, with different material types being transported to different locations. The question of what was actually being mined is worth considering. The material being extracted from the canyons was not necessarily worthless rock. It could have been rock containing valuable minerals or elements. It could have been processed to extract specific minerals, metals, silicates, calcium compounds, which were then transported elsewhere, while the processed debris was deposited in the deserts. The systematic nature of the mining suggests that particular materials or minerals were being targeted, not simply random excavation. The evidence of tool marks and systematic cutting in canyon walls, which we examined earlier, supports the interpretation that systematic mining was occurring. The step patterns visible in canyon walls are consistent with the systematic removal of material in layers. The geometric regularity of the cuts suggests that the extraction was organized and coordinated, following a plan. If systematic mining was occurring, the evidence of that mining would be visible in the way the material was removed. The question of who conducted such massive mining operations when the operations occurred, and what technology was employed to remove such enormous quantities of material remains unanswered by the official geological narrative. The narrative does not acknowledge that mining operations occurred at all. The narrative treats the canyons as natural features created through water erosion. The narrative treats the deserts as natural landscapes created through climate and wind erosion. The alternative interpretation, that both canyons and deserts are products of human activity, that material was systematically extracted and deposited, is not investigated. The suppression of this alternative interpretation follows familiar patterns. The deserts are treated as natural landscapes, and therefore the question of their composition is not a serious geological question. Researchers who propose that deserts contain mining debris are marginalized. The evidence that desert composition is inconsistent with natural desert formation is not emphasized in geological literature. The relationship between canyons and adjacent deserts is not investigated. The questions about where canyon material has gone are not asked. What remains is a landscape that tells a story very different from the official narrative. If anyone is willing to read the story written in the composition and distribution of desert material, the story is of massive excavation operations, of material being systematically removed from canyon systems, of debris being transported and deposited in adjacent desert regions. The story is of a constructed landscape created through human activity at a scale that is difficult to imagine. The story is written in the composition of desert sand, in the distribution of particular minerals, in the particle size distributions and sorting patterns that do not match natural processes. The deserts of the American Southwest are not deserts in the sense of natural arid landscapes. They are dumps. They are constructed landscapes created through the deposition of mining debris. They are the visible evidence of operations so massive and so systematic that they reshaped entire regions of the continent. They are evidence of technology and organization capable of removing mountains of rock and processing that rock into useful materials. They are evidence of a history that official narratives deny and that institutional authorities have chosen not to investigate. Walking across the desert, standing on the ground, touching the sand, all of this is walking on, standing on, touching the debris of mining operations. The desert that appears empty and barren is actually a filled landscape, filled with the processed remains of excavated material. The desert that appears to be a natural feature of the landscape is actually a constructed feature, created through the systematic disposal of mining debris. The evidence is beneath our feet, in the composition of every handful of sand, in the distribution of every mineral deposit. The evidence is visible to anyone willing to look carefully and ask the questions that the official narrative refuses to ask. The implications of understanding the deserts of the American Southwest as mining debris, rather than as natural landscapes, are profound and challenging to the official narratives about human history. If the deserts contain debris from massive mining operations, those operations represent evidence of sophisticated organization, advanced technology, and sustained effort over extended periods. The scale of the operations would have required resources, planning, coordination, and knowledge. The operations would have required populations capable of undertaking such work. The operations would have left evidence throughout the landscape. The question of when such mining operations would have occurred is central to understanding their implications. The deserts have existed in their current form for millennia, according to the official narrative. If they contain mining debris, the mining would have occurred before the deserts took their current form. The mining would have occurred during a period when different climatic conditions existed, when different populations inhabited the region, when different levels of technology were deployed. The mining would represent evidence of a period of human activity in the American Southwest that the official narrative denies or minimizes. The evidence that populations of significant size and sophistication inhabited the American Southwest during periods before the arrival of European explorers is documented in multiple forms. Ancestral Puebloan populations built sophisticated structures, maintained complex agricultural systems, and organized themselves into coordinated societies. But the ancestral Puebloans were not the first sophisticated populations in the region. Evidence suggests that other populations of unknown origin and organization occupied the region in earlier periods. The mining operations suggested by the desert composition could represent the work of these earlier populations. The question of what technology would have been necessary to remove the volumes of material suggested by canyon excavation and desert deposition is worth considering. The official narrative suggests that pre-Columbian populations in North America lacked the technology to undertake such operations, but the evidence of the deserts themselves suggests otherwise. The material has been removed. The material has been transported. The material has been processed and sorted. Technology capable of accomplishing these tasks must have existed. The evidence we have examined in previous discussions, the precision of stone cutting, the geometric patterns in canyon walls, the use of electrical power suggests that the technology available to ancient populations was more sophisticated than the official narrative acknowledges. If such technology existed, the mining operations that the deserts represent become more plausible. Advanced tools, advanced power sources, advanced transportation systems would have made the removal and processing of enormous quantities of material feasible. The question of what was actually being extracted through these mining operations is particularly significant. If the material in the deserts represents processed debris, what was extracted? What materials or minerals were valuable enough to justify removing hundreds of millions of tons of rock? One possibility is that particular metals or minerals were being extracted: copper, gold, silver, or other valuable elements. Another possibility is that the excavations served purposes beyond simple mineral extraction, that the creation of the canyons themselves served some purpose, perhaps related to water management, territorial organization, or infrastructure development. The systematic nature of the mining suggests that it was not random or opportunistic, but was planned and coordinated. The material was not simply removed and dumped randomly. The material was sorted, processed, transported in an organized manner. Some materials were kept and transported elsewhere. Other materials were deposited in the deserts. The systematic nature suggests that the mining served particular purposes, that the materials extracted were valuable in particular ways, that the entire operation was designed to extract particular resources while disposing of waste material. The suppression of this alternative interpretation of the deserts has been systematic and complete. The deserts are presented in textbooks as natural landscapes shaped by climate and erosion. The composition of desert material is not seriously investigated as evidence of mining debris. The relationship between canyons and deserts is not examined. The question of where canyon material has gone is not asked. The alternative interpretation that deserts contain mining debris is not treated as credible because it has not been seriously investigated. The suppression serves particular interests. If the deserts are understood as mining debris, it implies that populations capable of undertaking massive mining operations inhabited the American Southwest. It implies that these populations possessed advanced technology and sophisticated organization. It implies that the official narrative of pre-Columbian North America as relatively simple and primitive is incomplete or incorrect. It implies that something important about human history in North America has been obscured or suppressed. The suppression also affects how contemporary society understands the landscape. If the deserts are understood as natural features of the landscape, they appear as given, as unchangeable, as part of the permanent physical geography. If the deserts are understood as constructed landscapes, the result of human activity, they appear as changeable, as alterable, as landscapes that human activity created and that different human activity could potentially transform. The understanding of the landscape affects how people relate to it and what they believe is possible within it. The evidence of mining operations in the deserts also raises questions about environmental management in ancient times. If massive mining operations were undertaken, the environmental impacts would have been substantial. The removal of material would have altered water flows, would have affected vegetation patterns, would have created dust and erosion. The processing of material would have required energy and would have produced waste. The systematic deposition of debris in the deserts would have altered the landscape. The environmental consequences of such large-scale mining would have been significant. What this suggests is that ancient populations in the American Southwest possessed not only sophisticated mining and processing technology, but also understanding of environmental management. They would have had to manage the environmental consequences of their operations. They would have had to organize waste disposal. They would have had to adapt their operations to environmental conditions. The evidence suggests not simply that mining operations occurred, but that they were undertaken with a level of sophistication and planning that the official narrative denies ancient populations. The question of why such massive mining operations would have been undertaken connects to larger questions about the purpose and organization of ancient civilizations. The mining could have served economic purposes, extracting valuable materials for trade or use. The mining could have served political or military purposes, controlling access to valuable resources, demonstrating power and capability. The mining could have served religious or ceremonial purposes, the act of excavation and material processing being integrated into belief systems or ritual practices. The mining could have served technological purposes, the extracted materials being necessary for constructing other projects or maintaining other systems. Walking across the deserts of the American Southwest today, a person is walking across evidence of activities that the official narrative denies occurred. The ground beneath one's feet is not a natural desert, but a constructed landscape filled with the processed remains of mining operations. The landscape is a record of human activity written in the composition of sand and soil. The landscape is evidence of populations with advanced technology and sophisticated organization. The landscape is evidence that the history taught in schools and textbooks is incomplete. The deserts are also evidence of something else, of how effectively inconvenient truths can be made invisible. The evidence is everywhere. The composition of desert material, the distribution of particular minerals, the relationship between canyons and deserts, all of this is visible to anyone willing to look carefully. But the evidence has been made invisible not through being hidden, but through being ignored, through being treated as not significant, through being interpreted through frameworks that deny what the evidence suggests. Understanding the deserts as mining debris requires questioning the official narrative about the American landscape and about human history in North America. It requires taking seriously the evidence that the landscape itself preserves. It requires acknowledging that populations capable of undertaking massive mining operations inhabited the region. It requires accepting that the official narrative is incomplete or incorrect about the sophistication and capabilities of pre-Columbian populations. The suppression of this understanding continues because acknowledging it would require significant revisions to official narratives. It would require educational systems to teach different histories. It would require museums to reinterpret their collections and displays. It would require scholars to investigate questions that have been dismissed as not credible. It would require accepting that institutional authorities have misunderstood or misrepresented fundamental aspects of human history. The deserts remain, vast and visible, covering enormous areas of the American Southwest. The deserts contain within them the evidence of their constructed nature. The evidence is available to anyone willing to look carefully and ask the questions that official institutions have chosen not to ask. The deserts are dumps. The deserts are records. The deserts are evidence of a suppressed history, written in the composition of sand and soil, waiting to be read by those with the willingness to look beyond the official narratives and see what the landscape is actually telling about the past. What the deserts reveal, if their composition is taken seriously, is a history of human activity at scales that challenge conventional understanding. It is a history of mining operations so massive that they reshaped the landscape. It is a history of technology sophisticated enough to undertake such operations. It is a history that official institutions have chosen to suppress by treating the deserts as natural rather than constructed, by not investigating their composition, by not asking where the material removed from canyons has gone. The suppression is effective because the evidence, though everywhere, is made invisible through the refusal to acknowledge what it represents.